Hello, friends. So today we're going to start looking at right pyramids and cones. Yesterday we discussed prisms and cylinders, and we looked at how we would find the surface area and the volume of various prisms and cylinders. Okay, so we're changing to pyramids today and cones, but I've broken this up into two different lessons. We're going to do just the surface area today because there's some concepts that I really want to make sure you are comfortable with, and I want to spend one lesson on that, specifically what slant height is. And then tomorrow we will deal with volume, and then we'll carry on with a couple of other different shapes that we would have in this unit. Okay, so with no further ado, let's give it a go. So this is what a pyramid looks like. Okay, where a prism had two bases and was connected with rectangles. A pyramid has one base, and then we have triangular walls that fold up to a common point. Okay, so the triangular faces meet at the top of a three-dimensional vertex called the apex. Okay, I want you to know that word. The height of the pyramid is the vertical distance from the apex to the center of the base. So I want to bring up, I'm just going to circle this for you. It would be this guy right here. That would be the height of the pyramid. Okay. Now, what I need to talk to you more about, because that height people see and it's decently okay. What I need to talk to you more about is this guy right here, which you'll notice that I've marked with an S. The S stands for slant height. Now, slant height is the distance from the middle or center of the base of one side of the pyramid to the apex. Essentially, if I was to look at a net of this diagram, okay, so that's not a very good marker. If I was to look at the net of this diagram, it would look like this. If I collapsed all the shapes, it would look something like that, okay? The slant height is actually the height of the triangle, okay? Remember that to find the area of a triangle, we need base times height divided by 2, okay? So this would be the base of the triangle, this would be the height of the triangle, and then I would divide by 2. When I fold that over to make my pyramid, that height there is right there on the pyramid, okay? And what I need you to see is that's not the height of the pyramid, okay? In fact, that would be on a diagonal or a slant, and that's why we call it slant height, okay? But what does happen is the slant height with the height will form this cute little right triangle inside there. And so what often happens is we will give you the height when you really need the slant height, and then you'd have to use the Pythagorean theorem to get the other guy, or we would give you the slant height when you really need the height, okay? The slant height is what's used in surface area because surface area is all of the surfaces added together. Well, if I need to find the area of that triangle, then I'm not looking at the height of the pyramid, I'm looking at the height of the triangle, which would be denoted as slant height in the pyramid, okay? All right, good. So then the perpendicular height is the distance from the center of the base to the pyramid of the apex. So that would be the height, okay? So slant height is denoted with an S, and then the perpendicular height, that's the height denoted with a H, okay? All right, take these inks off for you. Okay, surface area of a right pyramid. Again, there is no formula. Don't get caught looking for formula. All you do is you add up all those sides. So you can see right now in a rectangular based pyramid, there will be 5 sides you have to find. You'll have to find the bottom and then the 4 triangles. The 4 triangles are only the same triangle if it's a square on the bottom. If it's a rectangle on the bottom, these 2 triangles will be the same and these 2 triangles will be the same, okay? And we'll practice that together. All right, so calculate the surface area of the following regular tetrahedron. Now, I don't know if you know what a tetrahedron is or not. A tetrahedron is essentially a triangular-based pyramid where all the triangles are the same, okay? So every one of these triangles has a height of 4.3 and a base of 5. So in a tetrahedron, there are now only 4 shapes. If I unpack that, I would have a triangle, and then that would be connected by triangles like that, okay? So I'd have 4 triangles, and in these ones, all the triangles are the same. So I would go 4 times the area of that triangle. Well, the area of that triangle is base times height divided by 2. So I'd go 5 times 4.3 divided by 2. Okay, and then we just stick that in our calculator and we get 43 meters squared. Remember to use your units, but surface area would be squared. So make sure you have the right units there, okay? Okay, a right rectangular pyramid has a base dimension 8 feet by 10 feet and a height of 16 feet. Calculate the surface area. Now, I want you to notice I did not give you the slant height. So this is where this question becomes a little trickier, and I want to go through it very, very carefully with you, okay? And the other thing I need you to see here is that there's actually 2 different slant heights because these triangles are not the same, okay? The triangles are not the same because we don't have a square on the base. So in order to handle this, I need to actually calculate 2 different slant heights, okay? So the first slant height that I'm gonna do is this red slant height right here. So let me just highlight that for you so you see what I'm doing here. I'm gonna find this slant height right here. So what I'm looking at is this triangle, okay? Where I know that the height, this length here, would be 16. And I know that the base of this triangle that I just drew has to be 5 because it would be half of whatever that is if this point right here is in the center, okay? And so what I did is I set up the Pythagorean theorem, 5 squared plus 16 squared, add those together and square root it. So the slant height there is root 281. Now we've had this conversation about rounding errors before. I'm gonna just leave that as root 281. I'm not even gonna try and simplify it because it's not part of my final answer, but I'm not gonna write it as a decimal because as soon as I write it as a decimal, I have run the potential of having a rounding error, okay? So now I'm gonna work on the blue slant height. The blue slant height is a little harder to see just because the orientation is different, but the slant height that I'm looking for, this is the slant height I'm looking for, okay? And now take a look, this is the triangle that I would be using right there. So I have a height of 16 still, but the base of this triangle would now be half of this side, which is 4, okay? So the blue triangle, I'm gonna go 4 squared plus 16 squared. I'm gonna add those together and take the square root. And so I'm gonna represent the slant height for EH as root 272. I'm not gonna do anything else with that, okay? Now, the other important thing, once we figure out the 2 slant heights, when you go to write the surface area, you have to be very, very careful that you put the right slant height in the right triangle. Okay, the reason I say that is this. Take a look very closely at this for a sec. When I did this slant height, I used half of this side in order to get the base. And so what happens is then students mix up, they think it goes with this triangle here, but it actually goes, it's the height of this triangle here for base times height divided by 2, okay? So for the red guy, that'll be the side triangle here, and there are 2 of those triangles, one on the left and right. So I'll go 2 times the area of a triangle, which would be 8 times root 281 over 2. Then I have 2, the front and the back, that would be 10 times root 272 over 2. And then I have the bottom too, don't forget the bottom, the bottom would be 10 by 8, okay? So here's my formula that I just kind of described to you. The bottom I listed in green, and then I've got the blue triangle and the red triangle. I type all that into my calculator. You should do that as well, just to make sure you're typing it in properly. And you should get 379 feet squared for the surface area, okay? That's probably, in this lesson, that's the most in-depth question I can give you, where you have to find 2 slant heights like that, and you have to make sure that the 2 slant heights are connected to the right triangles. Okay, so if you're a little overwhelmed at this moment, that's as hard as it's going to get for this particular lesson. Okay, Okay, so why don't we try another question like this, just to make sure we're comfortable with everything. So this time, I'm telling you the height is 5 centimeters. The dimensions of the base are 2 centimeters by 1 centimeter. And I want you to determine the surface area. It's the same question that I just asked you, except that there's different numbers. And I didn't give you a picture. So I might draw a picture out first, just to help yourself as you're doing it. So what I want you to do is pause me and then come back and see my answer, and we can compare answers together, okay? So here's my shape. I've got my height of 5. I've got one dimension of the base being 2 and one dimension of the base being 1. So I'm gonna go get the red slant height first. So I know the height here is 5. I know that this base right here would be 1. So I'm gonna go 5 squared plus 1 squared. That's gonna give me 26. And so I know that the slant height for that red portion would be root 26. Now I'm gonna get the slant height for the blue portion, okay? The height hasn't changed, that's still 5, but now this base right here has to be half of 1, because it has to be half of this side, okay? So that would be 0.5. So I have 0.5 squared plus 5 squared. That's gonna give me 25.25. So I can represent EH as the root of 25.25. Now, you would never say that as a number, right? We don't like to have decimals underneath roots, but this is a number that has absolutely no rounding error right now. So for the middle of the question, it is okay. So now when you create the surface area, we have the base, which is 2 times 1. We have the left and right triangles, which would be 1 times root 26 over 2. And then we have the front back triangles, which would be 2, the base, times root 25.25 over 2. Okay, so that's what it would look like all together. And then when I type all that in my calculator, I get 17.1 centimeters squared. Okay, awesome, guys. Okay, so now let's turn our attention to cones. Just like yesterday, a cylinder was kind of a special prism. A cone is kind of a special pyramid. Okay, with a cone, you've got a circle on the bottom, and that's your base, and then you've got this wraparound that comes to the tip. It still has an apex like that, but now it's just kind of one shape that gets wrapped around. Just like with a cylinder, it was one shape that got wrapped around the two circles. So a cone is a three-dimensional object with a circular base and a curved surface. Again, the height of the cone is the perpendicular distance from the apex to the base. And then the slant height of the cone is considered the shortest distance on the curved surface from the apex to the base. So now the difference here is in a pyramid, your slant height had to be in the middle of that triangle because it had to be the height of that triangle. This particular shape, I can actually put the slant height anywhere, and it's actually always going to be the same distance, so that doesn't matter, okay? All right, so surface area of a cone is the circular base, and then this is the wraparound. It's pi rs. Now, lots of kids are going to come to me and they're going to show me their formula sheet and they're going to say, hey, what's S? You know what S is, okay? Don't talk yourself out of your knowledge. We just talked about it. S is the slant height, okay? It is not the height. Be careful that you don't use height when you're supposed to be using slant height, okay? So pi r squared plus pi rs. Now, I also want to introduce the concept of lateral area to you. Lateral area is the area without the base, okay? And so here we can see that the base is a circle, and we know that a circle is pi r squared. So essentially, for the surface area of the cone, we would just take off the pi r squared, okay? So it's the area of a 3D object without the base. Okay, so calculate the surface area of this cone. Okay, so find the formula you need. Surface area of a cone is pi r squared plus pi rs. Remember to use the pi button on your calculator. We talked about that yesterday. Okay, so fill in what you know. I know my radius is 15, and I know my slant height is 20. Plug all that in your calculator. You should be getting, when rounded to the nearest square centimeter, 1649 centimeters squared. Okay, 1649 centimeters squared. Okay, calculate the surface area of the cone to the nearest square foot. Now, what I want you to notice here is I don't have the slant height. I was given the height. But again, you can see that same cute little right triangle in here. Okay, so I can use the Pythagorean theorem to figure out the slant height. I can go, the slant height squared is 7 squared plus 2 squared. So that ends up being 53, and I can represent the slant height then as the root of 53. Remember, I don't need a decimal here. I don't want a decimal here because I don't want to run into a rounding error. Okay. Okay, so now I can plug all this information into my formula. So surface area is pi r squared plus pi r s. And so that ends up being my radius is 2, my slant height is root 53. And now I just type all this into my calculator, and I should be getting 58 feet squared. Okay, 58 feet squared. Okay, the lateral area of an ice cream cone is 140 centimeters squared. The diameter of the cone is 8, and I want you to determine the height of the cone to the nearest tenth of a centimeter. So there's a couple things going on here that you need to see. First of all, we're talking about lateral area. So we're not including the circular bottom. So the surface area of a cone is pi r squared plus pi r s. We're going to take off the pi r squared because that's the base. So we're just looking at pi r s. I know the diameter is 8, which tells me the radius is 4. And so that's actually enough information to figure out S, but S is not the answer. They want the height of the cone. So once I figure out S, once I know the slant height, which is all I can do with that formula, right? But once I know the slant height, I can then use the Pythagorean theorem with that information to figure out the height, okay? So surface area is pi r squared plus pi r s, which means the lateral surface area will be just pi r s. I know the lateral surface area is 140, so I'm going to replace LA with 140. I know the radius is 4. Okay, so essentially to get S, I just have to divide both sides by 4 pi. Okay, and you can leave it like that, or you can write a decimal here if that is a little more comfortable to you. Just remember, if you're not opening up a fraction button and you're a TI owner, make sure your 4 pi is in brackets. Yeah, and now we're going to go and plug that into the Pythagorean theorem. So you should be getting a decimal approximation of 11.14084,602. And from here on in, when I go to the Pythagorean theorem, I'm just going to use the answer button so that I don't actually type that in again. That way I won't run into a rounding error or a simple typing it in wrong error, right? Okay, so S squared equals R squared plus H squared. I know what my S squared is. I know what my R squared is. So that's enough information to figure out what my H squared is, okay? So I end up having to subtract the 4 squared, and that's where H squared is going to end up being 108. Then take the square root, and I get, now that I'm at a final answer, I can do the rounding. It asks me to round to the nearest tenth. So 10.4 centimeters should be your final answer there, okay? Make sure you're rounding properly. Make sure you pay attention to the rounding, and make sure you pay attention to the units, okay? All right, so that's it for me on this lesson. You have some homework to try, and we'll catch each other up tomorrow when we talk about volume, okay? Have a great day, guys.